if the sum of all the roots of this equation is ln p, then we have to find the value of p. Now, this is a problem from quadratic equations, relation between roots and coefficients of a polynomial equation. First step, in place of e raised to x, we can write alpha, so that we'll get a polynomial equation. If we replace e raised to x with alpha, then we'll get alpha square minus 11 alpha minus 45 by alpha plus 81 by 2 equals to 0. And now to get a polynomial equation, multiply everything with alpha. So this is the cubic equation that we are getting, and let us say that the roots of this cubic equations are alpha 1, alpha 2 and alpha 3. Now corresponding to each root of this cubic equation in alpha, we are going to get one root for this equation. So let us say that the roots of original equation in x are x1, x2 and x3. So basically we have to find x1 plus x2 plus x3. Also you can notice that here they are asking sum of all the roots of this equation and not only the real roots, because if alpha is negative and alpha is e raised to x, so then we'll get imaginary value of x, right? Alpha cannot be negative for real value of x, but because we have to find sum of all the roots, we'll calculate x1 plus x2 plus x3. Now to find the sum of roots of this equation 1, we are going to find product of root in this equation. So in this equation, the product of all the roots alpha 1, alpha 2 and alpha 3, this will be minus 45, which is plus 45. Now alpha is e raised to x, so therefore alpha 1 will be e raised to x1, alpha 2 is e raised to x2 and alpha 3, this is e raised to x3 and this will be 45. And now we can rewrite this as e raised to x1 plus x2 plus x3 equals to 45. And from here we'll get x1 plus x2 plus x3 equals to ln 45. Now this is given as ln p, so that means the value of p must be 45. So the correct answer for this problem is 45.